This is Algebra 2, Lesson 8-6, factoring a sum or difference of cubes. Our objective today is to factor a sum and difference of cubes, sometimes with a greatest common factor. So I first want to talk about where these formulas come from very quickly, and then I'll show you 4 examples and we'll be done. So something interesting happens when you have a sum of cubes and a difference of cubes. Again, sum just means plus, difference means we have subtraction happening here. These are going to be cubes. One thing that's super important for this lesson is you need to have your perfect cubes memorized. Maybe I'll write those down at the very end. I do have a blue kit set up so you guys can memorize perfect cubes and higher powers that you will be needing in the rest of your Algebra 2 career. But interesting things happen when I have a sum of cubes and I divide it just by a plus b. This is just a total shot in the dark. I have a cube plus b cubed. What happens if I do a division by a plus b? Something unique happens. And this, I think, was probably discovered through trial and error, through human civilization. I'm not exactly sure, but watch what happens. Okay, so I know that this a cubed plus b cubed has to be the area inside of this rectangle. And I know I'm defined by a plus b. The answer is going to be on this side up here. So I need this area to be a cubed. I'm going to start on the left. So this has to be an a cubed. Well, this number times a gives us a cubed. So this number up here has to be an a squared. Okay, then if this is a squared, I multiply this column by this row. A squared times b is a squared times b. Okay, so now this area all has to, in fact, all of this area has to add up to this stuff up here. Do you see any a squared b terms in here? I don't, which means we need to get rid of this a squared b term, and the diagonals will always have like terms, so I need to get rid of an a squared b term. To get rid of an a squared b term, those are gone, but to have this negative a squared b, I have to multiply something by a. I need a negative because there's a negative there. I need another copy of an a and one copy of a b, so 1a, 1b is just a, b. Now, if I have negative ab times b, I have 2 copies of the b, and I have a negative ab squared. Negative ab squared. Again, do you see a negative ab squared anywhere in this area? No, which means I have to get rid of this negative ab squared by adding an ab squared. I don't really need to do the plus sign, so let me go ahead and erase that. In order to get an ab squared, this number times a will give me an ab squared. Well, I already have a copy of a right there. The only thing that I'm missing is a b squared. So I need a positive b squared term. B squared times b, last time I checked, is b to the power of 3. And check it out, we are supposed to have a b to the power of 3 right here. Notice that these cancel out, leaving an a cubed and a b cubed together, which means a cubed plus b cubed is the same thing as multiplying a plus b times this thing up here. So I already said that over on the side. A cubed plus b cubed is the same thing as multiplying a plus b times, I'm just going to kind of copy paste this over here, times a squared minus ab plus b squared. So this is one of the 2 formulas that you have to have memorized. The one thing that I want to point out is these 2 leading terms will always, or leading binomials, will always have the same sign. This is a plus, this is a plus, this is a minus, this is a minus to help you memorize that. And then you have to have at least one minus somewhere in your formula because the minus sign is either going to be the middle term or not at all. So again, we're going to go through this next one a little quickly, but you can kind of guess what's about to happen. So I need to have an a cubed term here. So this is the area, a cubed. And then I need to say what number times a gives me a cubed, that's an a squared. Then I multiply a squared times negative b for a negative a squared b term. I don't have any negative a squared b terms, so I need to get rid of this by having a positive a squared b term. The term that I need to multiply up here by a to get this a squared b term is a positive ab. If I multiply a positive ab times a negative b, I get a negative ab squared. And then finally, these 2 terms must be like terms. I need to get rid of an ab squared term because I don't have any ab squared terms over here. So I need a positive, and I don't need to write that positive. I need a positive ab squared term up here. If this is an ab squared, what term times a gives us an ab squared? We already have a copy of a, so I need another b squared term, and that's a positive b squared term. Check it out. B squared times a negative b is a negative b cubed, and as I already said before, those canceled out, and these will also cancel out, leaving behind an a cubed minus a b cubed, which is exactly that numerator without any remainder. There can't be remainders here, otherwise it's not a nice formula, right? Which means if I have a cubed minus b cubed, a difference of cubes, and I factor out a minus b, what's left over is always going to be this a squared plus ab plus b squared. So these, again, are the two formulas that you have to have memorized for this class. Again, I will point out that when there's a minus sign for the cubes, there's the leading binomial will have a minus sign. When there's a plus sign for the cubes, the leading term is a plus sign. The only change here is there's a minus versus a plus. These are all positive because this was negative. There's one negative because this one is positive. I don't know the best way for you guys to memorize this. If you guys have a cool trick that you can teach me or that you think is insightful, I can use it for the rest of my teaching career. So with those formulas, we can use that to factor anything that is of this form, a cubed plus b cubed or a cubed minus b cubed. So check this one out. I have a cube here and a cube here. If you don't know what this is cube, you need to practice that speed sheet or the blue kit. So first, this x is x cubed. I mean, that's pretty straightforward. But what number cubed gives you 343? Hopefully you know this. It's 7. So this is a sum of cubes. If I go back to my formula, which I can just copy paste, but again, you should be trying to memorize this formula. So let me grab this thing, copy it, and bring it down here, paste. This is our formula, and I'm going to write the formula down here. My A is going to be x, and my b is going to be 7. So I'm going to come down here and say that this is x plus 7 times, I'm going to square a, so this is going to be x squared, minus, I'm going to multiply it together, my a and my b, so a and b is 7 times x, or x times 7, doesn't matter, and this is 7x, and then finally I'm going to add a b squared term, I'm going to add 7 squared, I'm going to add a 49, and that's usually all you can do. For these I was going to say perfect cubes, but for the sum or difference of cubes, there's only one step and you're done. That's as far as you can go. I'm pretty sure this is never factorable, but I should really fact check that. I don't think you can go any farther with perfect cubes unless there's something really weird going on. So we're done. Get our final answer. We got 3 more of these to try, so let's do this. All right. Oh, by the way, one thing I should note, you always want to check for greatest common factor. In part A and B for example 1, I don't have any greatest common factor, and then I put greatest common factors in A and B on the example 2. So this one does not have a greatest common factor, but just to be sure, this number ends with 5, so clearly 5 is a multiple in 125. 5 doesn't go into 216. Maybe I can, maybe this one is divisible by 3, right? I mean, 216 is divisible by 3. If I add 2 plus 1 plus 6, that's going to be 9, and 9 is divisible by 3. But if you add 1 plus 2, which is 3, plus 5 is 8, that 8 is not divisible by 3. Therefore, the sum of these digits, or the number itself, is not divisible by 3. There is no greatest common factor for this difference of cubes. So what's left to do is I'm going to find a number cubed that is 216, and a number cubed that is equal to 125. Ooh, I was about to put 125 in there. Why did I put square there? Cubed, that will give me 125a cubed. The minus sign will just go in between. So I happen to know that if I multiply 6 and 6 together, that will be 216. So this is 6 cubed, and I know that this one is going to be 5, and I also need to have an a here, so it's going to be 5a, which means my value of a in my equation is going to be 6. My value of b, confusingly, is going to have this term a in it. It's going to be even more confusing if I do a b or a c, won't it? So let's go ahead and plug this into the formula for a difference of cubes. So again, we have this difference of cubes formula that you have to have memorized. I'm going to go ahead and rewrite this difference of cubes. I'm going to copy my difference of cubes formula, paste it down here. This is the formula that we're going to be using, so we're going to go ahead and plug in. We first have an a minus b. We have a, which is 6, minus our b, which is a 5a, and that's all going to be multiplied by a squared. So again, I have to square both 5 and the a. That's going to be 25a squared, 25a squared, and then plus I have to multiply a times b. So I'm going to multiply this 5a times 6. 6 times 5 is 30, so this is going to be 30a, and finally plus b squared. So again, I need to do, oh, did I just do, I fell into my own trap. This is supposed to be a squared, and I randomly wrote b squared, which I guess is fine in the context if I just switched a squared to be right here, but I want it to look nice for the note, so I apologize. Let me come back and make this look nicer and say that this is really a squared, which is just 36. I apologize. This one over here is going to be the 25a squared. So just clarifying, a squared, 6 squared is 36. B squared, this 5a squared, I square both and I get 25a squared, and I have my complete factorization done. I can go ahead and drop my answer. All right, so these next two have a greatest common factor. So let's go ahead and see what that greatest common factor is. So what can I divide each of these by? Well, I see that both of them have a c in it, and the largest degree here is a 1. The largest power is 1, so I can divide both of them by c, no other power. Can I divide by some other number, though? So 24 is even. Ooh, 192 is also even. So what could that be? If I just divide by 2, let me guess 2. So if I do 2, then this will turn into a 12, and divide that one by 2, that's going to turn into a 98. Ooh, I can do by another 2. So that will turn this, so dividing by 2 gives us there. Dividing by another 2 would give us 6, and that would give us 49. And this one is 7 and 7. That is a bad problem. What was I thinking? Did I make a mistake or oh my goodness, I see. 192 divided by 2 is not 98. It's 96. There we go. Because otherwise that would not work. 96, and therefore if I divide that again, that's going to be 43. Is it 96? I don't see what's going on here. I made this problem, and it's not working. 192 should be, yeah, it is 96. And if I divide 96 by 2, it's not 40. Man, my division is terrible. I am so sorry, guys. This is going to be, what is that going to be, 48? 48 doubled is 96. Okay, I got that one right. Whew. Sorry. Let's keep dividing. Divide by 2 again, right? If I divide by 2 again, this is going to be 3 and 24. And I can divide that one by 3. So divide by 3, and that's going to be 1 and 8. Oh my goodness. All right, so really the greatest common factor in each of these was 2 times 2, which is 4, times 2 again, which is 8, times 3 again, which is 24. Holy moly, the greatest common factor here was 24c. Okay, so that work unfortunately gets erased. And when I factor out of 24c, what's left behind? 24c times, I'm left with a 1c, I'm just going to say c to the power of 3, minus, and then 192 divided by 24, what do we say that was? Oh my goodness. I shouldn't have erased that work, shouldn't I? Darn it, 24 goes into 192. That doesn't help me. Oh, it's 8, isn't it? Because, let me just check. 8 times 4 is 32, and then 8 times 2 is 16, 17, 18, 19. Yeah, okay, so it's 8. Whew. Come back here and say that this is 8. Maybe it's too late. It's only 10:30. I can't use that excuse. Darn. All right. Anyway, we have our perfect cubes that are being subtracted here. So let's go ahead and I'm just going to rewrite the formula because I want to see if I have it memorized. I think the formula for a cubed minus b cubed is we do the same sign. It's a minus b at first, and then that rest is going to be addition. It's going to be a squared plus ab plus b squared. So in the context of this question, I'm going to have the 24c that's still factored out. And now I'm going to do the a minus b. So a minus b is, okay, well, this one is going to turn into c cubed minus 2 cubed, because 2 cubed is 8. Therefore, my a is c and my b is 2. So if I'm doing a minus b, I'm doing c minus 2. And then in here, I'm going to do a squared, which is now c squared, plus a times b, c times 2 is 2c. And then I'm going to square my b, so square the 2, and I get 4. So plus 4. And there's my final answer after like 2 or 3 mistakes. I don't really want to apologize for my mistakes. Those were good things. What did I learn? I need to be more careful with my division by 2. That's usually one of the easier ones. All right. I'm going to factor this one. And I'm seeing that this one doesn't have a W like the last one. Okay, this one ends in 4 and ends in 0. Both of these have to be at least divisible by 2. It might be bigger than that. We'll see. What if I divide both of them by 2? I have a feeling it's going to be nice because 54 divided by 2 is going to be 27. And that number is divisible by 3. This number doesn't have any divisibility by 3 because if I add all the digits together, it's just 2. So I think we're probably done after dividing by 2. If I factor out that 2, what's left over? I'm left with a 27w cubed plus 1000. Yeah, okay, that seems right. I don't think there's any other greatest common factor that I can factor out. So let me rewrite this in a slightly nicer form. This is 2 times, I'm going to change that to red, 2 times, okay, so 27, the cube root of 27 is 3, so it's 3w cubed plus 10 cubed. That means my value of A is going to be 3w, and my value of B is going to be 10. So let's go ahead and practice writing out the formula for a sum of cubes. A sum of cubes, if I have A cubed plus B cubed, let's see if we can have this memorized. Remember that you stay with the plus sign, so it's going to be A plus B, and then over here it's going to be A squared minus AB plus B squared. So I have the formula memorized, and then I just need to fill into the formula. So don't forget the 2 that's factored out. And then on the inside we have A plus B, which is going to be 3w plus 10. And then I'm going to do A squared, which is going, okay, so I have to square this number. When I square that, I'm going to square the 3, that's 9, square the w, that's w squared. So it's 9w squared, 9w squared, minus AB. So A is 3w, B is 10. If I multiply those together, I get 30w, plus B squared. 10 squared is just 100, plus 100. And that's all we need to do. So let's go ahead and box that for our final answer. All right, well, we made a few mistakes along the way, but we eventually got there. Our objective was to factor a sum and difference of cubes, sometimes that have a greatest common factor. Hopefully you're there. That concludes the notes for Algebra 2 8-6, factoring a sum and difference of cubes. Thank you for watching.